Welcome to another broadcast from MindYourHealthCast.com, bringing you breaking news. I say that because it seems that so many of the newscasts, that's the way they start out. We're bringing you breaking news. Sometimes it's actually broken. Anyhow, we are ready for another broadcast, and we want to bring to you a subject which over the years has cost me hundreds of hours of study and investigation and digging and pondering, and I've concluded that I still may not totally understand it, but I at least have some indications. So if you will stay with me, we will work at giving you some basic ideas and hoping, if nothing else out of this whole broadcast, you get the feeling that there's no such thing as a simple solution to a difficult problem. Now, you have probably heard, if you have not heard, alkalize. We are too acid. We have to alkalize. Everything is acid and we have to alkalize. There are books and books, one called Alkalize or Die. So I chose to call this broadcast pH in Life and Death. Now, that doesn't mean that we're going to be morbid about the whole thing, but even at death, there are certain things that are taking place in the body that are interesting, and that the Germans in particular, or Germans and French, have done a lot of research about the body, and there's a predictable capability if you look at certain numbers related to not just pH, because when we're talking about alkalizing, we're talking about pH. And I'm sure if you haven't heard by now, you will hear, and you'll probably see on the internet many articles about alkalization and why you must alkalize, etc., etc. But I can tell you that before this is done, hopefully you'll be ready to understand that over-alkalization is also a problem, and that homeostasis or balance is really what we're looking for. Now, I, as I say, have spent literally years and years. In my library, I just brought out one called The pH Miracle, Balance Your Diet, Reclaim Your Health. But the whole thesis of this is that this gentleman who wrote the book says that we are by nature alkaline and by function acid, which is kind of a catchy saying. However, I don't think it means a whole lot. Because it's not saying anything, but he is really saying that everybody's too alkaline and too acid, and everybody has to alkalize, or you're in big trouble. And he says you must restore the alkalinity because we are alkaline. Now, I don't know where he got the information, because in having read literally hundreds, if not thousands, of research studies, I haven't found anything that verifies that. We are basically alkaline, or supposed to be all alkaline. And as I say, it's really a matter of balance. So we really want to get into it, and as I say, it's not simple. Here's just one of the textbooks called Clinical Physiology of Acid, Base, and Electrolyte Disorders. This is all about pH and how it functions in the body, and what it does if it goes one way or the other, whether in health or in sickness. And so it's an indicator of imbalance if it goes too far one way or the other. Now, as I say, the alkalizing people would lead you to believe that it's all you have to know is whether you're acid or alkaline, and they give you a very simple test, which is very incomplete and inconclusive. In fact, sometimes when they think they're improving the condition, they're actually making you worse. And you'll get a little understanding of that as we go along. However, it is an interesting subject, and it is important, and anymore, people, of course, are using it as a merchandising tool I don't know how many doctors I have seen have jumped on the bandwagon that everybody is too acid and they have to alkalize. And so they have been peddling a very expensive machine, almost $4,000, to get you to alkalize all of your drinking water. And of course the machine can run it way up alkaline, up to the top of the scale. And they're advocating if you just drink that alkaline water, everything will be great. Now, what I'm going to say, and we'll talk about a little bit more, is that when the pH is off to one extreme or the other, it can shut down things in the body. And I know that the body's immune function at a particular area, and there's a big research paper on that. In fact, it's several pages long, and it has to do with something called extracellular acidification in inflammatory loci. Now, what they're talking about is that the body actually acidifies an area where the inflammatory process is taking place for a series of purposes. So basically, that means you have to have protons, and protons are acidic, and therefore you need that acid in inflammatory processes. Now, what happens if you flood the body with alkalinity and neutralize the acid? Of course, you're going to turn off the inflammatory process. Now, the inflammatory process is not bad, it's good, because that's the immune system at work. Now, we've mentioned this before, and I have to emphasize again that the 4 symptoms of inflammation or immune response is redness, heat, swelling, and pain. Of course, they're not comfortable, and therefore people don't like to be uncomfortable. But if you want your body to do its job when it inflames to get rid of something, it's important that we allow that to happen. Now, basically, the only thing you can do naturally is to give either herbs or homeopathics that help the body accelerate the process and get it over faster, that's all. But apart from that, you basically need to go through it. Now, of course, as I mentioned before, there is a 5th symptom, and sometimes if the problem is significant, the body will fever. And so that's that 5th symptom, and that's not fun either. But now medicine over the years has been very good at coming up with chemicals that will shut down the inflammatory process and will turn off the fever, and you feel better. The question is, are you better? And of course the answer is no. What is my proof? Look at the health of this country. Has the health improved by all this medical treatment over the years, by selling comfort? I think you'd have to be blind and not listening to the numbers as reported and watching the health, quote, sickness bill or costs go up the way it has. If it were working, we wouldn't have any of that. So if just turning off the symptoms made you healthier, everybody would be healthier. But the fact is that we are sicker, and the more antibiotics that people take and the more steroids to shut down the inflammatory processes in the body that people take, the less the body is able to do its job, and therefore the sicker we get. So then we come up with a deeper, more serious problem because the original problem was not handled, and then what happens? Then they say you have a new disease, and they give you a new set of chemicals that are going to try to manage or control or shut down that, only to lead you deeper. Now, if any of you remember or did hear the broadcast on homotoxicology, you would realize that every time you shut down the process, you drive the poisons or the problem deeper into the body, and the ultimate level is called the neoplastic or dedifferentiation stage of degeneration, which is cancer. So do we have less cancer today because we've done all of this arresting of symptoms based on immune response? The answer, of course, is no, it's not better, it's worse than ever. Back in, say, the 60s, maybe 1 in a couple of hundred people or more had cancer. And now the latest is 1 to 3, just recently I read, in women and 1 to 2 in men. So 1 out of every 2, or 50%, are going to have cancer in their life, and 33% of all women as it stands. However, that's still continuing to worsen. So answer is that something is wrong, and what is the wrong? Well, of course, it's the type of therapy. So at any rate, pH is important, and it is a set of numbers. However, you know, medicine started many years ago treating pictures and numbers. If they had a photo or a image, either by a CT scan, an X-ray, or a later MRI, and they could see a lump, then they had something to treat. If they ran a blood test and came up with a group of numbers and they found one or two numbers in variance from what they considered to be normal, which of course is not normal but standard or average, they then have to treat those numbers. So in a sense, anybody who is treating pH is treating numbers, and you really don't understand what that pH means. Now, to me, it's very important that we actually look at that, and as I say, if you take away nothing more from this, is that be careful about going to any extreme or buying expensive equipment that is going to feed you a bunch of highly alkalized water, which is going to attempt to try to push your pH. And as you'll see later when we talk about it more in depth, that when you treat acid urine by alkalizing, ultimately you make the urine more acid. And there's a reason for that, but only to say that the whole subject of pH is not that simple. Now, if we get into the definition side of it, we know that there is a technical definition which really says that pH is equal to the negative log base 10 of the reciprocal of the hydrogen ion concentration. Now that sounds kind of technical, and it is. But in essence what it means is it's a measure ultimately of hydrogen ions, and those hydrogen ions have an electropotential, and therefore it gives you some indication about this positive charges, because if you look at the definition, you find the H is followed by a positive sign, meaning that there is a positive electrical charge associated with a hydrogen ion, and hence it's referred to also as a proton, or a positive charge, as opposed to an electron, which has a negative charge. And so that's important, that we'll mention later, that you realize that, and that you realize also that pH is really measured by measuring voltage or potential. In other words, you're measuring an electrical potential, and it's measured in volts, and that is then converted in this equation to give you a logarithmic number that's on a scale of 1 to 14, or 0 to 14, depending on how you want to look at it. 1 would be the low number. But in that scale, of course, 7 is in the middle, which makes it neutral. So when you have a 7 pH, it means you have an equal number of positive and negative charges, if you want to look at it that way. And in essence, that's what it amounts to. So we're looking and talking about a battery. You know, the body actually is electronic in nature. I've said that before. And sometimes people don't associate pH with electricity, but in fact it is. And we'll talk a little bit more about the whole thing of how those interrelate. Now, there are so many myths out there about pH, and interestingly, I've read volumes of books and articles and heard people talk, and they're always talking about this alkalinity problem, but I'm looking, you know, where's the research that shows this to be true? Now, I understand that sometimes that if it's so new, that maybe not too much research is there, but then you cannot be stating it as a fact, you can only be stating it as an opinion. So at any rate, I've looked and found all kinds of articles related to pH, and what I found does not verify that the body by nature should be alkaline, and therefore if it's acidic, and of course the other problem is the measurement method that's being used, and we'll address that a little bit more later. But there's just so many myths out there about pH, and I have to say that it's not simple. The whole understanding, as I said, I showed you a big book, and there's books and books on pH, both from the research and scientific side, and books, of course, on opinions about too much alkalinity. I mean, too much acidity, so therefore the body needs to be alkalized more. So there's a lot of that out there. But anyhow, some of the myths that I thought are kind of interesting is, and this is the biggie, it is good to be alkaline and bad to be acidic. Now, I guess that's the big one, and I hear it over and over. I recently heard a broadcast by a local doctor who was just saying if you measure the pH of the urine and it's on the acid side, then you just drink a few gallons of this alkalized water and everything will be fine. Now that's not true, but what it is true, that as I say, if you have symptoms that are going on that are inflammatory in nature and you drink a lot of alkalinity or take a lot of alkalizers in the body, which are attempting to do that, and you override the inflammatory process, it's true, you will feel better. So if you're using symptoms as your criteria as to whether you're better or worse, then I would say you're better. But if you're using whether or not the body was able to accomplish what it was trying to accomplish, then I would say you're probably worse. So it's important that you understand that the symptoms are not the criteria. There was another researcher, and we'll mention him in a few minutes, by the name of Ravisi out of New York, and he was able to manipulate pHs and learned a lot about it, but he was an MD, and he kind of looked at it from the medical side, and not too much from the quality of nutrition. And so sometimes when he saw a pain, which he would call a alkaline pain, because he recognized it could go both ways, if he considered it an alkaline pain, and he had a way of determining what he thought was alkaline pain, he would feed the people cold cuts and sausages and all kinds of junk food, which would push the body the other way. Now the people would feel better. In fact, I know of a doctor over in New Orleans that a lady came to me that had a lot of terrible health problems and had for years, and she had all these symptoms which were really meaning her body was loaded with poisons and it was constantly trying to get rid of the poisons, but of course she was continually feeding the poisons. So she heard about this doctor in New Orleans area. She went over to see him, and his treatment was drink lots of Coca-Cola, eat lots of Snicker bars, and basically, she said, I have to admit I felt better. But in the long run, she got worse and worse, though. And temporarily, you can do that. You can throw things in the body that will push it temporarily one way or the other and make yourself feel a little better. But the question is are you better? Now, Dr. Hahnemann, in writing his treatise on homeopathic medicine called The Organon of Medicine, many, many years ago, in fact, way back in the 1800s, he wrote this organon, and he said the first and highest function of a physician is to determine what it is that needs to be cured. And by that, he was really saying, you have to know a lot about the person, their lifestyle, what they're doing, what their stresses are, what their attitudes are, what kind of food they're eating, all kinds of things, and determine if changing their lifestyle is what is really indicated. In other words, you don't have to treat every issue with some kind of pill. And so this ended up being a very basic tenet, and I agree with him that it still stands today. Before, many times you can do anything, you have to clean up the person's lifestyle, their environment, and their response to their environment before you can really get into correcting the problem. But anyhow, this first big myth, it's good to be alkaline and bad to be acidic. The truth is, it's bad to be alkaline and it's bad to be acidic if they're in the extreme. But you never hear the alkalizing people say, well, you know, you got to watch you don't get too alkaline. You just got to keep alkalizing and alkalizing and alkalizing and drinking more of this water. And I hate to laugh, but when I hear it, it's funny because I know that the person who's stating this, number one, never really thoroughly studied the subject. If they did, they would realize how little they know about it. And number two, trying to do one little thing, very simplistic, is not, as a rule, going to correct a serious problem. In today's world and in our society, with all the things that are going on, most of the people have very serious problems. And so just allowing or getting someone to think, if they would do that, that everything would be great. Now, this is a researcher that has spent a lot of time looking into things, and he was talking about the fact that people that he sees tend to be probably at least 70% of them are on the alkaline side already, if you know how to look. And you can't do it just by measuring the pH of the urine, I can tell you that. But anyhow, here's what he said are the symptoms that he's found associated with too alkaline. Hypothyroidism, hypochlorhydria, which means not enough stomach acid, allergies, wheezing, diarrhea, fatigue, feel more like the tortoise and less like the hare. In other words, you feel like you can hardly crawl along, and elevated serum bicarbonate. I'm going to throw this in right at the moment because to let you know what that means, elevated serum bicarbonate. Now, if you've ever had a blood test, did you ever see on that blood test one of the factors that says blood bicarbonate? And of course the answer is no, because it doesn't show on there like that. Now, why they do it the way they do it, I cannot say. And it is difficult, of course, to know something about blood pH, other than the fact that the body makes it stable as it can make it, because it cannot vary very much if you have good health. And so there is on the blood test a factor that, if you're aware of it, will tell you about the bicarbonate in the blood, even though it doesn't call it bicarbonate. And the number is the CO2 factor. Now, why they chose to call it the CO2 factor, I don't know. Well, maybe I kind of know, but it's not important. The fact is that when you want to know something, if you have a current blood test and you want to know something about the pH of the blood, you can look at the CO2 factor, which is really bicarbonate, which is the alkaline factor in the blood, and you can look at the chloride, which is shown as one of the electrolytes. And if the chloride is higher, even though in the median range of what they call the median or normal, and the bicarbonate is in the low range of the normal or average, then you could say probably the blood is slightly toward the acidic side, but not much, because the body won't allow it to go very far. And if you see the bicarbonate up toward the upper side, which is the CO2 number, and the chloride on the lower side, then you would know that the blood is tending more toward the alkaline side. So that's kind of a general rule, but again, it's not highly perfect, but it will give you an indication. And of course that range is kind of wide, that median range. And if you see those numbers like that, if both of them are toward the middle more, then you can say it's probably pretty balanced in the range that it's supposed to be. So that's a good indicator. But it's, as they say, and I don't think even a lot of doctors know that, that's what the CO2 really is, that the CO2 is the bicarbonate. Now, of course, the body wants that blood to be very balanced, getting to what I said earlier about extremes. It doesn't want it too far one way or too far the other. It needs to be balanced. And so it actually does things to keep it from going too far either way. And they're called buffers. And throughout the body there are buffers, and buffers, their job is to keep the balance as much as possible. I mean, not that it can't be pushed off if it's pushed hard enough, but under normal circumstances it keeps it level. And so bicarbonate happens to be one of the buffers to keep it from getting too acid. On the other hand, chloride is in there to keep it from going, and I don't know that it's really considered a buffer, but the chloride keeps it from going to alkaline. And if you understand that, it can give you a little help in reading a blood test. But there's another buffer in the blood too, which is albumin, which is a again, is a protein factor in the blood, and it can grab onto certain elements to keep the blood from going too far one way or the other, or let them go as is needed. And so the body has all these protective systems if you allow it to work. Now, what happens if you suddenly keep flooding the body with huge amounts of alkalinity? That would be the same as taking a box of baking soda and keep shoveling teaspoons of baking soda down. Something's going to go wrong after a while. And guess what? I had a guy, this has been several years ago, who somewhere got this idea that the body is too acidic, and because it's too acidic, then we have to alkalize. And so every day he poured in huge volumes of baking soda. Now, interestingly, as he did that, the urine got more and more acidic to the point that it was actually burning the ureters and the bladder and the urethra, and he had a terrible problem and was having trouble getting it back. He came to see me once or twice, but he just didn't give it enough time. But I knew immediately when he told me what he had done, how he had thrown it way off balance. Now, did he alkalize the urine? No, actually it became more acidic, and as I tell you about something later, you're going to know why. So anyhow, that's a big myth. And so there's some other myths, that most people are too acidic, and as I say, it's not really true. You find that if you know how to look, that probably more of them are on the alkaline side already. Meat is acid forming. That's another one of the myths, and that's not necessarily true. It depends on what your metabolism and your digestion does with the meat. And the same thing that myth number 4, that vegetables are alkalizing. That's not necessarily true either. Myth number 6, the most accurate measurement of a person's pH is through urine and saliva, which is not true. It can be helpful, but it has to be considered in light of the overall picture. And so when we talk about BEV in a little bit, you'll understand why that's true. Another big myth is that high saliva or urine pH, 6.8 plus, indicates a person is alkaline. Well, no, again, all this is just things that you hear that they're hearsay, and then they keep getting repeated. And there's a couple more, but we won't take the time to get into it. I always have to watch the time because it creeps by fast. But just to give you an idea that there's a lot of mythology related to pH. Now, one of the best books, which unfortunately is probably going to be very hard to find because I think it's out of print. I studied in Germany, and I studied with one of the top doctors, well, more than one, but this one in particular, who used a system that we're going to talk about in a minute called bioelectronics Vincent, or according to Vincent. And it was abbreviated BEV, and it's called acid-base balance in theory and practice. And so this is a very good book. If you can find a copy of it someplace, it's called the New Medicine Series, and it was written by Helmut Elmau, MD. But I've looked and I can't find it available anymore. But in a very concise little book, it really gives you an understanding of this acid-base balance and how it involves a lot more than just measuring urine or saliva pH. It gets into the whole dynamic of how those all interplay, because they all interact with each other and they all have reflection about certain aspects of your health. At this point, I want to talk about some general considerations and mention that, first of all, in the body, the 3 major organs that have a lot to do with pH, period, are going to be the lungs, the kidneys, and the liver. The liver deals a lot with the metabolic side. The kidneys and the lungs both deal with discharging a lot of the toxic material out of the body. And it's important that they stay within certain ranges for it to work properly, because there's such a thing as respiratory disturbances in the pH and urinary or kidney disturbances in the pH. And it does attempt to regulate that to some degree to keep the body in balance. In other words, it can blow off, the lungs can blow off certain things, especially if they're volatile in nature. And the kidney, of course, gets rid of the fluid things in the body, and it works at helping keep the blood in balance. And therefore, the urinary system, in some respects, relates to the blood. So it's important that you know that all of those work together. So that's the first thing that you need to know, that those are heavily involved. And the second is body compartments. I think the biggest frustration with dealing with people is that, again, it's not that simple. The body is divided into a lot of different compartments, and those different compartments have different pHs. And it's especially prevalent in two areas, the digestive tract, and secondly, the interior of cells and the organelles within the cells. So it's important that you understand something about that, how that it's different pHs in different areas. And so it's kind of difficult to talk about the body a certain way. In other words, I've heard people say, well, the body's too alkaline, the body's too acid. And I say, well, what do you mean by that? Well, we measured the urine, or we measured the saliva, we measured both of them, and therefore we determined it's too acid or alkaline. But again, it depends on where you're looking. I have all kinds of articles and studies I mentioned about when the body immune system is working and inflammation takes place, how there's a shift in pH. Well, anyhow, here's like a whole big study called The Importance of Being Acid, the Role of Acidification in Intracellular Membrane Traffic. Now, this is all about how important acid is to the function of cells, basically. And another one called the regulation of intracellular hydrogen ion concentration, again having to do with what's going on inside the cells. pH homeostasis of cellular organelles, how the body works to keep the balance of pH in different compartments inside the cells. I mean, it just goes on and on. The regulation of organelle acidity. Now, how does that sound in light of the people talking about alkalizing? Here's one on low pH in cancer, and it's interesting because if we have time, we'll talk a little bit about that. But, you always hear everybody say cancer loves acid, and when you're too acid, you make cancer, and, that's not really true. Cancer, like any other living organism, has an operational range of pH. And that operational range is not that it loves acid at all. In fact, the reason somehow, I'm guessing, it got associated with it is the fact that cancer cells make energy by breaking down glucose via glycolysis, which is a fermentative process, and the byproduct of that is some energy and lactic acid. So there is excreted from the cancer cell lactic acid, which is the byproduct of energy production in the mitochondria. That is not to say then that the cancer loves acid. It just says that it produces acid in the process of making energy. Whereas a normal cell, using something called oxidative phosphorylation to make energy, breaks down the food products ultimately into energy, with the byproduct being carbon dioxide and pure water, neither of which are problematic. The carbon dioxide is slightly acidic, produces something called carbonic acid, moves back into the bloodstream and is blown out through the lungs, as we were talking about how the lungs help control the pH. The water, of course, is either used or discharged through the kidney system. So here we get back to what I said earlier, that the lungs and the kidneys have a lot to do with the balance of pH in the blood. So here's another one: restore your body's health and build your immune system with pH balance. So there's just piles of stuff written And as I say, I've spent years and waded through probably thousands of research articles and certainly dozens of books, if not more, on pH. So as I say, we have to realize that there is no single pH that runs through the whole body, and in particular inside the cells where all the functional things take place. Inside the cells, energy is made, the DNA is held, the DNA process of replication, building new cells when they wear out, the DNA is coding for different proteins that are necessary for body function, which is the production of amino acids, or using amino acids, I should say, to build protein. All of these things are going on, but the heavy stuff is going on inside the cells, and it's very hard to measure the pH. Some of the research people have worked out some sophisticated ways of measuring inside, and were quite surprised when they saw the variations of pH within a single cell, within the different compartments within that cell. So it's not simple to say the body is alkaline or acid. It really, to me, doesn't have much meaning. Now, we need to consider digestion and elimination, because that's an important factor and a big starting point for basically your health. And again, digestion is not that simple. We need to take a real fast excursion. Of course, as I say, we're always limited to time, but we'll take a fast excursion through, and maybe this might be 2 parts. I was asked by the producer, is this going to be a 1-part or 2-part? But now that I look at this, it's possible. That time just goes skipping by real fast. Digestion. Nothing gets into the body unless it's digested and absorbed. Now, it's interesting because there's an old saying you've heard many times, you are what you eat. And I remember a professor of anatomy and physiology many years ago saying, bah, humbug, that's not true. It's not what you eat that makes you what you are, it's what you eat and gets inside you that makes you what you are. So remember that topologically, that's a type of mathematics, there's no difference between a human body and a donut and a coffee cup. Visually, we can probably picture it better as the donuts. You know, the donut has a hole, and you can drop through something from the top of the hole, and it falls out the bottom of the hole. And our digestive tract is exactly like that. It starts at our mouth, runs all the way down through our body, and out the other end. And you can put things in it and go all the way through and out the other end and it not get inside your body. It went through a tube that goes through the body, but it did not get inside your body. And it's getting inside that's what makes it useful. And to do that, it has to be broken down and put in a certain form, and everything has to be working right to make that happen. And of course, as I say, it has to be the right thing too, because if you eat the wrong thing, it could be a problem. You know, like if you drink a glass of arsenic solution, it'll probably get inside you, but you don't want it inside you because it's going to be very devastating. So to understand digestion is not that simple, and I think right off, this is getting back to the compartment thing, this is one of the areas right from the beginning that you need to understand that there's different pHs in different areas of the digestive tract. For example, under normal conditions, if you measure the saliva of a healthy person, it will likely be about 6.4 to 6.6, which is slightly acid. Okay, so right off, it's not alkaline. Now, there are people, and I've read in some of the books and material that's put out, that people are saying that pH of the saliva needs to be alkaline. Well, if it is, things are not going to, it'll be a reflection something's really wrong if it's showing alkaline. Excuse me. And so maybe we'll get to that, I'll see. But the point is that under normal conditions, if you measure it, and there's going to be reasons to believe it should be 6.4 to 6.6. Maybe on occasion 6.8. So that's what it starts out at. Now, it does make a shift. And when will it shift? It will shift when you put something in your mouth that has carbohydrate in it, such as a piece of starch or potato or whatever, the first stage of carbohydrate, complex carbohydrate digestion starts in the mouth. So the saliva under normal conditions would be slightly acid, but if you put a piece of potato in your mouth or a cracker and start chewing on it, you will notice that after a little bit it starts to take on a sweet taste. And the reason it does that is that right away the saliva shifts from being slightly acidic to considerably alkaline. If you took the pH right at that point, you would find that it was alkaline. And so then that starts the first stage of carbohydrate digestion. Then all the food moves from the mouth into the stomach, and when it does that, the pH of the saliva will shift back to slightly acid again. Now, as the food moves into the stomach, something starts to take place in the stomach that it's no longer affecting the carbohydrate, because the first stage took place in the mouth, and therefore it's not going to go any further in the stomach. And the fats, nothing was done to the fats in your mouth or your stomach. Those are reserved now later for the small intestine. So when it gets in the stomach, whatever proteins are there, proteins are very complex molecules. It's some of the largest molecules in the body are protein molecules. Okay, so they're not so simple to break apart. You know, you have to have a lot of powerful tools to break it apart. And the powerful tool, of course, is enzymes. Now, in the stomach, the first step of protein digestion takes place. And everybody immediately thinks, the acid is what helps digest, or helps to digest a protein, or does digest the protein. The answer to that is that it's wrong. It does not. In fact, the acid has nothing to do, per se, with digestion. It actually creates an acidic environment for the pepsin, which is another enzyme, to actually begin the first stage of protein digestion, which is to shear apart these large protein chains into smaller chains of amino acids called peptides. And so pepsin is the enzyme that does that. But for the pepsin to work properly, it requires an acid environment, in fact a highly acid environment, because enzymes are pH sensitive. Now, we've talked about enzymes a little bit before, but enzymes actually have three factors that they need to work properly. One is pH. Number two happens to be water. And number three, meaning the amount or deficiency of water. And number three is temperature. So different enzymes have different requirements in terms of pH, water amount, and temperature amount. So if any of those three are not present properly, it is unable to do its job properly. So if, for example, you're low in stomach acid, which can happen if the body's way off balance, if you're low in stomach acid, then guess what happens? Pepsin cannot do the first stage of protein digestion properly. Now here's the point, again, we need to insert about the modern treatment of reflux. Now reflux, of course, it talks about the fact that the stomach contents are pushed up into the esophagus and irritate the lining. Probably 99 out of 100 doctors will tell you that means you have hyperacidity and give you either an antacid or a proton pump inhibitor, which turns off the production of acid in the stomach, and or H2 inhibitor, which old Tagamet was an H2 inhibitor, which shuts off the whole process because it affects the nerve information, or not the nerve, but the messengers, one of the messengers that tells the stomach to make acid. And so consequently, those will turn it off. And they're saying you have too much acid, that's why you have reflux. Now the fact is that when you have reflux, that means you are low in acid. And you might be shocked to hear that. Some people would be. But the fact is that the acid sends out a signal in the stomach that it's being released and starting digestion, and so the valve from the esophagus into the stomach tightens up tight to hold the contents in the stomach so that it will not come back up into the esophagus. And of course the valve on the other side of the stomach that empties into the small intestine is tightly closed, and so now the stomach has a motion that's triggered, which is like a massaging motion that stirs up all the contents of the stomach and mixes it with the hydrochloric acid and the pepsin, and their job is to start that first stage of protein digestion, which is to break the complex protein molecule down into peptides. Now, when our body's not working right, and you don't have enough protons in the stomach or acid to make the right pH, which is very low, plus or minus 2, which is extremely acid on the acid scale of hydrochloric acid. So if you don't have enough, guess what? There's another signal that can be sent from the stomach saying, okay, the pH is down now, and the digestive process in the stomach is about over, so you can relax the valve from the esophagus. And when you do that, it allows the food to be pushed back up into the esophagus because the stomach is still churning. Now, the esophagus lining is not built to withstand either extreme, acid or alkaline. And here again, we need to tell you that alkalinity in excess is no better for your body tissue outside the stomach than acidity. Alkalinity is a base, and of course then you have the acid, and sometimes that's what you hear. It's called acid-base balance. Okay, so bases are alkaline in nature, and when they are high alkalinity, guess what they do? They dissolve tissue. When they have made skeletons from human skeletons for medical use and so forth, they need to clean all the debris of muscle and ligament, well, not the ligaments, but the muscle tissue and all that kind of stuff off of the bones to make it nice and clean. And so guess how they do that? They put it in a caustic bath. Now the word caustic means that the alkalinity dissolves that tissue. So whether the contents of your stomach being pushed up into the esophagus are acidic or alkaline makes no difference. The lining of the esophagus is not made to handle an excess of it. So either one will actually destroy. The acid will burn, but the caustic will actually dissolve the tissue. So guess what happens with medicine? Since they decide that the proton is too high, meaning you're too acidic, then you've got a big problem. And that big problem is that you're going to have not digesting the protein properly. It's not going to happen. What happens is that when you have too little acid, it is going to be a problem because you can't break down the protein. And if you can't break down the protein, the first stage of it in the stomach, then the second stage of protein digestion in the small intestine is not going to work right, so now you've got an additional problem. And so you need the acid in order to get the protein. Now why do you need protein? You need the amino acids from the protein to rebuild new heart tissue and to rebuild new muscle tissue and to rebuild new cells in the body, and to build chains of amino acids that form hormones and enzymes in the body. So basically you don't function well without it. Things start to come apart. And I'm thinking of all these people now that are given all these proton pump inhibitors, like the purple pill and Prilosec and all of these. Guess what they're doing? They're making a big problem. Now, I've mentioned before that there's a second problem with all that. Not only do you become deficient in protein when you block the acid in the stomach, you have a second problem, and that is if you turn off the acid totally, the valve from the stomach is going to dump the stuff prematurely into the small intestine, and that protein not being digested cannot be then finished digesting by the proteases in the small intestine, which now require an alkaline environment, and so the pancreas releases bicarbonate into the small intestine to move it from being acid in the stomach to more alkaline in the small intestine, because those enzymes require alkalinity. And so those proteases were designed to break short peptide chains apart into individual amino acids. Now, if they haven't been broken down into peptides, it's got a big problem to try to get much out of that. So now you have protein that is not broken down into individual amino acids. It stays together as protein, and guess what happens in a dark environment with a lot of warmth and a lot of fluid is that the protein is going to rot, basically. And in the process of rotting, it's going to form ptomaines. And ptomaines are extremely toxic. I'm sure you've probably heard of ptomaine poisoning, which is rotting meat, rotting beef, rotting pork, whatever it is, produces ptomaines. The same as the human body, when it dies and starts to disintegrate, produces ptomaines. And those ptomaines, the two main ones are called putrescine and cadaverine. And so that you're building a lot of ptomaines in your body when you can't break down your protein properly, so you're beginning a low-level poisoning of your body from it. Just so that you understand. So now we have the mouth being acidic before putting complex carbohydrates in. It temporarily goes alkaline, but then goes back acidic. The stomach being highly acidic, requiring the high amount of acid to make the pepsin work properly to do the first stage of protein digestion. You have all this moving into the small intestine, the pancreas now emptying bicarbonate into the small intestine to neutralize the acid so that it can be a bit more alkaline so that those enzymes can work to finish the job of digestion. So if everything is working right, the second stage of protein takes place with the proteases from the pancreas at an alkaline pH. The lipases start breaking down the fats if the body liver is working properly and producing good bile, and you haven't had your gallbladder cut out so that you can't concentrate the bile is going to emulsify the fats so that the lipases can break them down properly. And then the amylases are going to finish the second stage of carbohydrate or sugar breakdown. And all those enzymes require alkaline environments. So now you have acid mouth, slightly acid mouth, highly acid stomach, alkaline small intestine, and then in the small intestine, once these things are all broken down, the ones that the body needs get absorbed through the wall of the small intestine if it's working right, and if you have the proper bacteria there, and if you haven't messed up the whole environment of the small intestine or damaged it by eating large amounts of the wrong kind of foods. Then from there it goes into the large intestine, where it's now acidic again, and it does the final removal of some minerals and water and so forth, and then it's eliminated from the body. So look at all those shifts that are going back and forth in those compartments just in the digestive tract, and just to get the stuff ready to get into your body and to get rid of the byproducts or the debris. So the digestion and elimination is a tremendously important part of the whole process involving pHs. And I've mentioned about the stomach acid, and I mentioned that if you're eating the right food, because I'm absolutely convinced, I've worked in this health field going on 40 years, and I am absolutely convinced that the genetic related to blood type carries certain antibodies that recognizes certain foods as being bad. they're bad for you. Now you know that the body has an important job of keeping you from being injured or killed. Your body is very protective of keeping you alive and keeping you healthy if it can. We do everything, it seems, today to counter that by putting all kinds of poisons in the body, by pumping in all kinds of junk food, wrong kinds of food, food that's deficient in nutrients, and then somehow expect that we won't have symptoms. But we do have symptoms, and we go get drugs which further mess up the body to try to manage those symptoms so we feel better, but at the same time our health is going down the drain. So in a nutshell, that's a bad problem. Now, those dietary foods are primarily proteins that are problems. Now, you know that in nature, the things that are very toxic to your body more often are protein in nature. Remember I said enzymes are actually made from amino acids, which are protein builders in nature. Now, to give you a good example, spider venoms and snake venoms and so forth are enzymes. And those enzymes are designed to break things down, and that's why they're toxic. They're either neurotoxic or cytotoxic. That means that they either affect the nervous system in a bad way or they affect poisoning the cells in a bad way. They poison the cells. So your body's job, one of its jobs, is to look at everything coming in and compare it to its library of antibodies, which are the defensive network for things coming into your body to keep it from being damaged or destroyed. So, if you have antibodies against certain foods in your blood and you take in, or in your body, and you take in the wrong food, the proteins in that food can be recognized by those antibodies as being an enemy or dangerous to your body. So the antibodies then will attack those to neutralize them. And so that's why you get a food reaction to the wrong foods because of your blood type. Now, it's not that the blood type causes it, it just happens that those antibodies related to proteins that could be damaging to your body are carried on the same genetic structure that carries the blood type. And so it's not the blood type per se, but the fact that it's on that same genetic grouping that those antibodies are programmed or actually produced. In other words, the coding is there to make those. So I'm a type A blood, so I have a high level of antibodies against beef and heavy proteins. And so when I eat those, my system is not geared to handle it, and because it's not geared to handle it, I have a big problem. If I eat that, it taxes my system and in a sense poisons it because I can't really break it down very well. Now sometimes you can offset that a bit by taking extra enzymes if you want to and try to make it work, but the real issue is you need to learn to eat the right diet. Now, I've known for many, many years, even before I ever heard of the blood type diet, that there were certain foods that my body did not do well with, that it caused me trouble. I had picked them all out, and when I first heard of the research of this particular person, Dr. Powers and his wife Laura, they had done all this work and research. They had a clinic up in Maryland with a group of doctors, and they did blood studies. They didn't just guess. They actually had blood studies done of reactions to different foods. And so they had worked out from their studies in general, the types of foods that each of the blood types could not tolerate well. And I heard about their work. I took their training program, and sure enough, everyone that I had taken found out, actually, that was bad for me was on their list bad for type A. And I found out the same thing related to O, that the people that I had as patients who were O's, that they could not be a vegetarian, even though they wanted to be, and I was, and do very well as a vegetarian. Type A can be a total vegetarian. And so if you take food in that's the wrong food, number one, it doesn't get broken down well, like the proteins in the stomach and digestive process. Therefore, in the small intestine, they end up acting as antigens that provoke antibody reactions, and so you've got these allergic reactions. The bad thing can be that it can be a delayed reaction, 1 to 3 days after you eat it, so many times people don't put it together. So the pH in the stomach is weaker in a type A because it doesn't need to break down all that heavy protein, and that's why it taxes your system, if you're type A blood, to eat heavy beef and pork and game meat and all that. Your body is not geared to that. Some light fish, if you're going to eat meat, and maybe some white meat, chicken or turkey, coming from organic sources, are okay occasionally, but much, much better in fruits and vegetables, especially high levels of vegetables. Okay, I guess we're about to run out of time, as always, and I'm probably going to have to stop here because we've got a lot of good stuff yet on pH that it's going to hopefully bring this all together for you. And I'm going to talk about some of the systems that have been generated, and pH is a high level factor in that system of determining what your health is and whether or not you're improving your health. And so we'll talk about those in nature. There's at least 3 major ones, and there's probably a lot of subsystems, but there's at least 3 major ones. And we'll talk about a few more considerations such as stress and the effects of the sympathetic parasympathetic nervous system, and the blood pH and oxygen is something important that we'll talk more about that when we have the next broadcast. It's nice to be with you again, and I hope you go to our website, mindyourhealthcast.com, and look through it. And if you're interested in something about the clinic, alternative health and prevention, you can click from that website to the other website. And of course, you know that we're being broadcast now on YouTube, so we hope you tell a lot of your friends to come to it. And if you go to our website, be sure and register on there. We have a place that you can give us your email and so forth. Not that we're going to harass you trying to sell you something, but we do send out announcement of the nature or titles of the broadcasts and any other important information that you might want to know, because sometimes we want you to go to some other website and look at other information that's out there. And so that's the type of thing you're going to get. You're not going to be hounded with a pile of email trying to sell you something. We do have some things for sale on our website that I recommend, and occasionally people will be interested in purchasing those, and that helps to finance our broadcast. That's why we can bring it free and spend a lot of time in research and purchasing of books and research studies and all that to keep current with all the information that's out there. So we look forward to seeing you again at the next broadcast. Until then, be healthy.